So there's a couple of ways that we can calculate an approximate mass of sample that we need to collect and the number of samples we need to collect to get a certain precision and relative error. So let's do that for an example. Say we have a number of 10-gram samples and we took 5 of them and we got values of 1.24, 1.78, 1.62, 1.34, and 1.87 milligrams per kilogram. Now what we need to know from this, and these are 10-gram samples, so we'll put that in. Let's say they're 10-gram samples. So we can find the relative standard deviation of those samples if we know the mean, and the mean in this case is 1.57 milligrams per kilogram, and the standard deviation is 0.273 milligrams per kilogram. So now we can put them into an equation. Calculate R, the relative standard deviation. The relative standard deviation is just the standard deviation divided by the mean multiplied by 100. So in this case it's going to be 0.273 divided by 1.57 times 100, and that equals 17.4%. As a relative standard deviation, that's really not very good. We're usually looking for below 10%. So let's figure out what mass we would need to get a 10% relative standard deviation. First thing we can do is find this constant by multiplying the mass of our samples by the relative standard deviation. And if you had different sample masses, you would get the mean as the mass m here. But we're saying they're all exactly 10. So 10 times 17.4 squared gives us this k value of 3028. Now what we'll do is we'll plug this value back into this equation as k and then solve for m, saying that this is what we want, which is a 10% relative standard deviation. So we can do that. We'll just rearrange that equation, and that gives us m equals the constant divided by r squared. So our k value was 3028. R squared we want is 10, so 10 squared is 100. And that's going to give us a value of a little over 30 grams. So we're saying to get a 10% relative standard deviation acceptable precision, we need to have samples of about 30 grams instead of 10 grams. Now the only thing we can do is figure out how many samples we need to collect in order to get a acceptable kind of relative or acceptable error. In this case we're going to do percent relative error. And the equation we use here is the value of t, which we look up from the t table, squared times the standard deviation squared of the sample. Now we're going to use a relative standard deviation. If we use a relative standard deviation, then we can use the relative error. Remember, error is our value, or the mean value divided minus the true value. To get a percent relative error, we're going to divide that by the true value, and then we're going to run out of space, but you would then multiply by 100 to get a percent error. So we have to be sure to be consistent. So if we're using the relative standard deviation, you also need to use the percent error. So let's say we want to get a percent error at 2%, 95% confidence of 2%. So we want 2%. So what we're going to do is plug into that equation, and as the only really way to real way to save or to solve this is to do it in a kind of iterative way. And what you do is start off with the value of t for n equals infinity. So our table will have that. You can look up n values for different amount of numbers of samples. Since that's what we're trying to find, we'll start off with just the infinite value and see what we get. And then we're going to multiply by the standard deviation, or in our case relative standard deviation squared. Remember, we found that was 10. We used our 30 gram samples. So 10 squared, and the relative error we're looking for is 2% relative error, so that's 2 squared. And that gives us a value, our first value of 49. Now if you look up in the table the value of t for 49, the closest is 50. We'll put in that value, which is 2.009, and do the calculation again, and we get a value of 50. And if you were to plug that in, obviously the value of t would be the same. So this is the iterative approach. In this case, we were pretty close to what we the value we wanted anyway. But what you would do is start off with this n equals infinity value, and then whatever number you get is what you look up for the t for the next iteration. And you continue until you get two answers which are the same or similar. If we did it again, we would get the same number. So this now says that we would need to collect 50 samples, or 30 grams, in order to get percent relative error of 2% and relative standard deviation of 10%.